Go for it.
Okay.
Wait, so how about the really?
Right? Or two, right?
Did you see
Nailed it.
Abanya's nice dive? I'm not
His
pleased.
dive that he didn't catch it?
Yeah.
Yes, I did.
I'm not pleased.
Didn't Hunter Pence miss one too?
Yeah,
Should've
again,
got-
he missed this one the other day.
He couldn't.
Abanya
Was I
missed
couldn't remember if it was last night or the night before. But so what? I mean, you figure the Braves are playing like for everything right now. Do you know that? Like the Braves like might not make it in, whatever.
Kind of awful.
So the
Right
Phils
now.
don't really have to play for anything, so it's pretty good. Okay.
I have extra 30 seconds out of that.
You know I have tickets to Saturday's game and I'm not going.
Wait, I thought Kate was baby.
What?
I thought Kate was baby.
She's babysitting next Saturday. Does she know that?
You better call her quick, too, because she told me something that she had work, so she couldn't run in Hopedale and...
No, it's not this Saturday, it's next Saturday.
Okay, well, you bet. Text her.
Seriously.
Okay, I will.
That'd be bad.
I'll be
It's Eliza's birthday this weekend. That's why I'm not going to the game.
Oh,
Take him
wait,
to the game.
Same
Yeah.
as my grandma. That's how
Oh
I
my
remember.
God.
Kindred spirit.
Okay.
Monday.
Alright. So what you have to remember with this
What just happened?
is that when you do the chain rule, you gotta take the derivative of the outside thing first and chain on the derivative of the inside stuff. So now it gets tricky with the trig. This first one's not that bad, but what's outside? Sine or x squared plus x? Sine, right? So I gotta take the derivative of sine with respect to whatever's inside. I'm gonna leave that alone. So the derivative of sine is cosine of the stuff that's there. And now multiply by the derivative of the stuff that's there. 2x plus 1. And that's that derivative. So it's the derivative of the outside thing with respect to what's inside, don't change it, and then multiply on the derivative of the inside. You what?
That's not bad.
No. It just gets bad in after a while.
The last one.
Okay, I have the next two up because they're really similar. Don't, she's not going to tell her on the bus. Don't worry.
She is. It's okay, I'm hanging there.
But she can just tell her I don't have to. She doesn't have to.
She's like playing a phone with it right now. She's like nervous too.
Yeah, she should be. It's
Yeah, she
Hopedale.
should.
She could have told me no.
We had SATs, and then we
I
put her
know.
out there. And then she was saying, I don't need her to get her out of space. And that.
Alright, anyway.
I'll be.
I put these here because they're very similar, but completely different. They look really similar, but you actually handle them very differently. Okay, this is just the cosine of 3x squared. 3x squared is like the term that you're taking the cosine of. This one, if I rewrote it, is cosine of 3x. The whole thing's to the second. So get the difference? Okay, so when that little 2 is in the middle, it really means the whole cosine's to the second. Well, here's how different these derivatives are. This one's pretty easy. Cosine's on the outside, the derivative of cosine is sine. So the sine of 3x squared times the derivative of 3x squared, which is 6x. Now, I wouldn't leave it this way. There isn't a whole lot you need to do, but like any terms like this or constants I would bring to the front. So this is a negative 6x times the sine of 3x squared. Okay, it's not wrong this way, and if you left it this way on a test, it would be right. It's just kind of annoying. That's better. Okay. The derivative of cosine is negative sine, I was told. So it is that. It's weird. Alright, so here's the harder one. When the whole trig function is squared, I'm going from the outside in. So my squared is on the outside. So that's what I'm going to deal with first. So to take derivative, bless you,
Thank you.
I'm going to bring the 2 to the front. I leave this alone for now and subtract 1 from the power. Bless you. So all that happened is your power comes to the front, leave this alone and subtract 1 from the power. But now, I have to take care of that. Well, what's the derivative of the cosine of 3x? It's still a chain rule problem. So I got to look at the outside is cosine x. And the derivative of cosine is negative sine of 3x. But this isn't just an x. So now I have derivative of the 3x, which is 3.
Okay.
Because, do you agree, like, as an aside, that if my function is the cosine of 3x, the derivative of that would be negative sine 3x times the derivative of 3x, which is 3. If you see just this, it's kind of easy, like derivative of cosine with respect to 3x times the derivative of 3x. But within this context, it's a lot trickier, because I've got the power rule happening first, but then I'm still left with the derivative of this. Well, the derivative of this requires its own chain rule to happen. What people get wrong is they chain too many times, and they think you should keep going. Well, if I kept going, I would eventually end up to 0, and everything would cancel, and the whole thing would be 0, and that would make no sense. So here's what I do to figure out how many times I chain. If I look at the original function, I want to think, like, how many things are happening? Well, I've got if I look at this one, I've got a squared, that's 1. I've got a cosine, that's 2. I've got a 3x, that's 3. So I need 3 derivatives. I need the power is the first derivative, the derivative of cosine is the second one, and the derivative of 3x is the third. So however many things are being done in the original function, that's how many times I'm going to take a derivative. Does that make any sense? I'm not seeing any nods. That's not good. Okay, we'll keep going and we'll see how it goes. This one, pardon me, is the whole quantity squared or just the x? Just the x. So if I'm going to take the derivative of this, how many things are there? There's a cosecant and there's a 2x squared. So there's only 2 things. So I'm only going to take 2 derivatives. What's the derivative of cosecant? Negative cosecant cotangent. So the derivative first is going to be negative cosecant of 2x squared times cotangent of 2x squared. Because this 2x squared, I'm just leaving alone. I'm just taking the derivative of the outside thing with respect to what's inside. And now I have to multiply by the derivative of the inside, which is 4x. I don't multiply by 4x twice. Even though the derivative of cosecant was 2 separate things, it doesn't matter. The derivative of cosecant is cosecant cotangent. It's like one term. So then I take the derivative of the inside, and that's 4x. It only happens once. So if I was going to clean it up a little bit, I'd have negative 4x, cosecant 2x squared, cotangent 2x squared. Is that okay? Alright, take a second, try this next one. This fourth in here means the whole quantity is to the fourth.
If you can't read that, that's secant 4x squared to the fourth. It's really far away.
I'll move it back over here. So you can
Okay.
say.
We're going to move it over here for you.
Uh-huh.
I got this.
Jimbo.
Just for Jimbo.
I'm not moving it for Jimbo. I'm moving it for
Try that on your own. See how you do. Yep, I went too far.
went too far?
Yeah.
No, 8?
Yeah.
Yeah. Think about it this way. How many derivatives, like, how many rules up here do you have to use? I have to use power rule for the main power of the fourth. I'm going to have to use the derivative of secant for the secant part. And then the derivative of 4x squared can all be done at one time. So this doesn't count as like two separate things. So I take, I do the power rule first, bring the 4 down, make it a 3. Then the derivative of secant is secant 10. Then the derivative of the inside is 8x. And that's it, I don't do any more. If I do more, I'm done too many. Because think about it, you could keep going forever. I could take the derivative of n times 8, and then the derivative of that is 0. And then the whole thing is 0, and you messed up. So knowing when to stop on the trig ones is the hardest part. Does it make sense?
Yes.
Okay. Alright, last one I moved over for the benefit of the camera. Okay, realize here I am not saying sine of x. This is the sine of the cosine of 6x squared minus x. So how many things are happening? I'm taking the sine of something, then the cosine of something, and then I've got this term. And this last green underlined term is one thing, because I can take the derivative of it at one time. It doesn't require like multiple steps or anything. So this derivative, the derivative of the outside, so the derivative of sine is cosine with respect to everything that's in here. Now I take the derivative of the inside. This inside has cosine on the outside, so it's times a negative sine of 6x squared minus x. And now I need the derivative of the inside, which is 12x minus 1. It doesn't get much harder than that.
Sure.
What's that? Yeah, for chain rule. Not like in the class. No, I know. Alright, try a couple of these.
What?
While you try this, can I check your homework from last week?
I didn't do anything.
The 3 assignments are up there. If you were absent yesterday, can I check yours tomorrow? I mean, if you're absent today, can I check it tomorrow?
You're asking the camera that? Oh, the camera's gonna end.
You know what? Now I know why your dad gave me that slash badge.
All the empty seats.
Yes, you put a trap there. Say it on camera.
What was the homework?
What's that? Those 3. Okay, so I'm going to come around and check. Page 120, 129, and 140. 120, 129, 140.
120?
129 and 140.
20. 29.
Yeah, I can't find one of that. I know I did this. I don't think we did, or you probably like collected it or something, because I can't find 120.
I have 120.
But you didn't. I know you
120 is just MIA.
For both of you guys?
What? No, because I did what I did last week, and I just started on one page and continued straight through for all my homework that I did on Sunday. And now 120 is not there.
Never
Huh.
mind.
Oh, I need them.
I mean, I'm really not here to... I can't think of a way to say it now that the camera's rolling. I'm not here to bust your chops, so like, if you think you did, if you're saying you did it, you can probably pause it while we go over stuff.
Be right back.
Yelling at us.